Now I would like to tell you that the non-bonding electron can also move. These are, suppose, let me draw it like nitrogen. These are the lone pairs or non-bonding electron of nitrogen, and here I am going to draw a double bond. So again I should write the same type of the arrow. Now here is a double bond, and in the previous example, as you saw, that the molecules or the electron will move only when there is a vacant orbital or a conjugated single and double bond. Again, this bond is in conjugation with a single bond, and now those electrons can move and form a bond here, and this electron will shift to that carbon. The same situation is here. So the same arrow. Okay, now the electron moves, but this time something else will happen. Now CH, I should write it like this, and CH2. This is negative. Now in the previous example, as you saw, I should rewrite the pi electrons moves, and those pi electrons sit here. Okay, and then this carbon acquires a positive charge, but here the lone pair or the non-bonding electrons moves. So what will happen? The nitrogen here forms a bond, an extra bond with its lone pair. So it was initially neutral, but now its lone pair is part of a pi bond, so it acquires a positive charge. As two electrons move away from it and form a bond, so it will acquire a positive charge, and the electron sits on this carbon and it will acquire a negative charge. Okay, so I hope you understand that what is happening, and as I will move step by step to a moderate level. So this is a very simple example. I just want to show you that which electron moves. Okay, now there is another thing, that suppose you have a double bond in conjugation with mean that a single bond separating the two pi bonds, a triple bond. What will happen? Okay, suppose this is H. If this is a line, this means it is a CH3. Okay, so let me draw H's here. Now suppose these electrons can come here and these will shift here. It will produce a negative charge on this carbon, or these electrons will come here and this will sit on this carbon and will create a negative charge on this carbon. Now those tools of the inductive effect and the electronegativity will help you to understand that what will be the actual structure, but right now I just want to show you that how the electron moves. Okay, so I should need to write it a little bit quicker. Okay, what happens? This will be the next structure. This is the arrow for resonance. Now electron left this, and a double bond appears here, but here one bond move and another double bond is left, and here is an H. As the valency of this carbon is satisfied, now what happens? A negative charge will sit here. This is one form, but there you can form there can be another form also, another resonance form, which is like, what if these electrons the electrons on the triple bond moves to this carbon and they sit here. Okay, we still don't know that which one we need to prefer, because according to some rules and some previous knowledge, you will then know that which structure is good or which structure is bad. Okay, we are not focusing on that right now. Now these electrons move here. These are the two H's. This is the CH. This is a double bond. This is a double bond, and this is H, and now a positive charge appears here. So this thing is negative. Still, you will be thinking that I am moving electron in that way, in this way. So what is the actual way? So right now the aim is not to show you that what is the correct way, which way is preferred. Either the electron from a triple bond to a double bond is preferred, or from a double bond to a triple bond is favored. It will be clear to you when we will be discussing the rules of resonance. I just want to show you that what are the legal moves in resonance. Okay, we are just focusing on the legal moves. So these are the structures which could be drawn. Again, there are some molecules or there are some moves which are legally forbidden, or they don't resonance don't allow them to occur. Okay, the concept of resonance, in the concept of resonance, they are not allowed. Okay, that is, suppose you have a double bond and you have a sp3 carbon or saturated carbon, or it doesn't have any other pi bond, so it is sp3 carbon. So the movement of these electrons from here to here is wrong, because there is no double bond here which will move its electron away from it, as there are 3 hydrogens attached to it, so they cannot move. So this resonance form this cannot be a resonance form. This thing is wrong. Okay, so it is not possible. The only resonance form which is possible is, in this molecule, is either these electrons can come here and sit on this carbon. We still don't know that what will happen. Okay, plus, and why I am doing this, you will understand it after a while. Now this is the CH3. This is the arrow of resonance. Okay, but as you know that these electrons can also move in the other way, like this. When they move in this way, the situation will be different. This is our CH2. Now it becomes negative. This is the CH. Now this become positive, and this is the CH3. Okay, but still we don't know that this is good or that is good, because we will be discussing it later. So right now we need to understand it, how the electron moves and where the electron moves. Okay, which electron moves and where the electron moves. So this is another thing which we need to understand. So let's come to the non-bonding electrons. These are non-bonding electrons. I am writing nitrogen. You can have oxygen because it also have a lone pair, suppose, and here you have a CH3. This move, it is again not correct, because it is sp3 carbon and it doesn't have any electrons which or any pi electrons, or it is not a vacant orbital, so this move is not legal. As I mean that if it was like this, these are lone pair, oxygen has 2 lone pair, okay, so I should write them. If here was supposed to be a double bond, then now this electron can move here and those will move here, okay. So what would happen here? You will see H O plus double bond CH CH2 negative, okay. It could have happened. This is correct. This thing is wrong because it is sp3 carbon, okay, or saturated carbon. It cannot move. And here when the electron shift, there are some electrons which can move away, okay, the loose electrons, the pi electrons. Here they are strong electrons, sigma bonding, CH sigma bond, so that don't move. Another thing is the electron doesn't move to every positive charge. As you see, suppose this is a double bond, okay. Before studying the rule, we just need to study the moves of electrons. It's also a part of the rule, but it's a minor part. The major part is we'll be studying it a little after a while, okay. Now we have an H or H. Here a positive charge is present on it, okay. And I would like to write a hydrogen with this carbon. So this is again not a legal move because there is no double bond that it will move away from the nitrogen. So this nitrogen again is sp3, or it is fully saturated. It doesn't have any double bond or a pi bond which will move away from it. And the difference between this thing and this thing should be kept in mind. Look at this thing, CH2. As you know that when CH2 has some positive charge, this means that this thing has a vacant p orbital. So the electrons can move into the vacant p orbital. Here the nitrogen, all the valencies are satisfied and there is no vacant orbital present on the nitrogen, though it has a positive charge. This thing has a positive charge too, but here there is a vacant space or p orbital available which can accommodate those 2 electrons. So here the resonance form is okay, and here the resonance form is not okay. So we should also remember that the electron should not be moved to all positive charged atoms, as this is positive charged atom, but it is also electron deficient. This one is positive, but it is not electron deficient, okay. Let me show you another example. Suppose you have nitrogen lone pairs and you have a boron BH2. As you know that in boron, when boron when it forms 3 bonds, 3 covalent bond, it is always sp2 hybridized or sp squared hybridized, so there is always a vacant orbital on it, okay. Now this is a little bit interesting. Now these electrons comes and sit here. What will happen? The nitrogen, because it was a neutral thing, it will acquire a positive charge, a double bond is produced here, but another thing happens, that is the boron will acquire a negative charge. But remember, I am not writing any lone pair or non-bonding electron on the boron. So why? It will be clear to you with this example. look at this, negative or positive, okay, and these are the CH3s. Suppose this is a nitrogen, again it could be hydrogen or oxygen or other atom with a lone pair, and either here we have CH and here we have CH2. Now when those electrons move here, something you will see that what happened. This is the resonance arrow. Nitrogen as usual will acquire a positive charge, write the CH on its place, and here the carbon acquire a negative charge, but this negative charge and this negative charge is different. Here the negative charge means that lone pair, okay, I should write the lone pair starting from the middle, it sits on the carbon, but here in this case the lone pair just forms a bond. So this is a negative charge, it is just a formal negative charge which shows that the boron forms more bonds and some other electrons came to the boron as in the form of a bond, but here the electron came and sit right on the carbon. So along with this negative charge I should write the non-bonding electron too. So that's how when you write carbon or carbonyl, you need to write the non-bonding electrons here, because it will be quite difficult. Sometimes people like it like this, and there is now no difference between this carbon with a negative charge and this thing. Negative charge is nothing, it just shows that some surplus electrons came either in the form of a bond or either sits on the atom, okay. So don't be confused with those two things. Some people might be thinking that this is a lone pair, it has some double negative charge, it has a non-bonding electron and a negative charge. No, just because of those non-bonding electron you need to write a formal negative charge on it, okay. So this is the very basic of resonance, and I hope you understand it, and thank you very much.